In section 15.6, we'll apply all the work that we did in section 11.7 on parameterization to the job of evaluating various types of integrals on surfaces. The first example we're going to do is finding surface area. So let's suppose that phi is a parameterization of some surface in space. So the surface lives in XYZ space, and we're parameterizing that using some region in the UV plane. So points in R get mapped over to points in S. So what I'd like to do is figure out how areas in S compare to areas over in R. So we might think about taking a very small rectangle here and seeing what it maps over to here. And I'd like to figure out what the magnification factor is in terms of areas. Well, if I take the little vector along this horizontal edge of this rectangle, then that maps over roughly to a tangent vector to the surface S. Now notice here that I'm moving horizontally, so U is changing and V is not. So that's going to correspond to taking a derivative over here of the parameterization with respect to U. So d phi du is going to be a tangent vector to the surface S. Similarly, if I want to see roughly what this vertical edge is taken to, then over here I'm holding U constant and letting V vary. Over here, this edge of the shape in the plane is going to be approximated by the vector d phi dv. So the area of this little region in S is approximately the same as the area of the parallelogram spanned by d phi du and d phi dv. Well, way back at the beginning of the semester, we figured out how to find the area of a parallelogram in space. You took the two vectors, in this case d phi du and d phi dv, we took their cross product, which is a vector, and then we took the magnitude of that cross product. So this is equal to the area spanned by those two vectors. So based on that, we define the element of surface area capital DS, so this is big DS, to be the magnitude of d phi du crossed with d phi dv times du dv. And then if we want to calculate the area of the surface S, that'll be the double integral over R of ds. So in the next video or two, we're going to calculate the area, the surface areas of various surfaces, and it's going to be a several-part process. First of all, we'll find the parameterization phi. Then we'll calculate d phi du and d phi dv, take the magnitude of the cross product, which will give us the area element. Then we'll have to integrate that over the region R.